Ugh. Penny is pulling up her stuff. We're not just sitting here looking at each other.
Good.
Okay.
I could tell that's what you were wondering.
Okay. Can everybody see that? All right, Candy, I will let you kick it off, and I will try to move slides for you when you give me the cue.
Okay. I was thinking since we actually have switched groups this time, I'm not sure if the other data was the same. So, Penny, do you want to give them the background information first again that you did last week? You remember that?
Not really. I didn't prepare.
Okay.
You have to do that. So like,
No.
yeah, they have the same tasks with you.
Okay, it was the same. So you know about what our data actually covered. Okay, great. Okay, so Johan will go to the next slide. Okay, basically our data this week was, he had divided it into 3 separate types of teachers for the data, and then we were to find different information based on certain characteristics of it. So the first type was type 1, and so what we did was filter that information of type 1, and so that if they were type 1, we were to get the mean and median of their self-evaluation for phonics, the grade teaching, and years of experience. So in the table you can see that the mean was 2.7 roughly for how the teachers evaluated themselves for phonics, and also their average for the grade that they taught was 3.3, and then they had about a 6 years of experience. Now type 1 was teachers that scored at least 1 standard deviation below the mean on phonologic, you know what I'm trying to say. And they scored on or above the mean on those non-skills from there. So that was type 1, and that was their mean, and then the median from that. And moving on to type 2, we were looking at the grade teaching, years of experience, and then their self-evaluation on comprehension. And you can see the mean on the grade teaching and then their self-evaluation for comprehension. 3 was the mean for the score and 3 was the grade teaching, but those aren't going to be like similar means because it's evaluating different things. And then the years of experience was around 11 years. And then the type 3 teachers, we were looking at the grade, years of experience, and then the self-evaluation for comprehension and phonics. So the first one was just phonics, then self-comprehension, and now we've put those both together for type 3 teachers. And if you look at the mean for those, you can see those grade teaching, the average was about 2.7. Now the years of experience goes a little higher here at 18.5 being the average for that. And then the self-evaluation for comprehension, they gave 2.86, and then self-evaluation for phonics was 2.86 as well. And so looking at those charts, Penny's going to take over and tell you some key findings and implications that we found for this.
Thank you, Candy. So one of the things that we wanted to acknowledge is the fact that all of our groups that we looked at, once we sorted out those specific groups of type 1, 2, and 3, represented a small or minimal sample size. So each of them being type 1 being 6 teachers, type 2 6 teachers, and type 3 7 teachers. We noticed that the type 3 teachers, those are the ones that scored at least 1 standard deviation below the mean on the I'm getting like Candy now, that's in that word, non-phonology, and at least 1 standard deviation below the mean on phonology had that average of 18.5 years of teaching experience. So these are not our new teachers. They are veteran teachers. They are serving our early elementary school students. And we're talking about their self-ratings, which always makes me think of our teachers' efficacy and how do they feel about their skills. And we would think, just thinking, not looking at data, we would think a veteran teacher with basically 20 years experience would have that in their head, that self-efficacy. They would feel better about their knowledge, their ability to impact students, their awareness of instructional practices. You would think that it would be better than that, but we see in this data set that it's not always the case. And efficacy is a huge part of working with teachers and helping them to build that self-efficacy. And what does it mean in regards to their practice? So some of the things that we talked about that we would do as an administrator leading teachers is to provide some of the following actions. So additional collaborative measures like you would have in professional learning communities, opportunities to observe other teachers during specific lessons that deal with the phonology or non-phonology components, coaching support. We often think, well, they're a veteran teacher, they should be mentoring another teacher, but that's not always the case. Teachers are at all different levels regardless of their years of experience. They may have been moved around from grade to grade. And as you know, when we are leading teachers, a lot of times it's like going back and being a new teacher again when you have to jump from one grade level to another, especially if you're going in a small district like my own. They might go from the K2 span to the 3-5 span. Sometimes they're even going into middle school or coming back from middle school into elementary. So we have to make sure that we have that coaching support in place, whether that's a teacher coach or a teammate or even an administrator. Very intentional professional development would be needed because we know that these components are critical for all learners. It's going to help them build their foundation for language and literacy skills. Candy, would you like to add anything? I think you're muted.
Sorry. I think you hit everything that we talked about. We were really focused on the type 3 teachers because that did stand out with their not feeling confident in their abilities to teach that. And it was obvious in the data that it was the veteran teachers that were feeling that way. So that was the main thing that really stood out to us.
Do you all have any questions?
Yeah, can I say something?
Sure.
Yeah, thank you, Candy and Penny. Like that was an awesome job, and you made a great improvement based on the last time, because last time you had 40 slides and now you have maybe just 8, 9, and the information was clear and concise, very good. So like perhaps I just want to say that in the future, like I know I'm kind of imposing my data to y'all, so and you perhaps don't have the background knowledge, but if possible in the future, to relabel the type 1, type 2, type 3 to a more specific teacher type that could like improve your communication or knowledge, information delivery. So that's just a suggestion. Okay. That's
okay. Thank you.
Yeah. Thanks.
Great job, y'all.
Yeah.
Thank you.
Cynthia and Tanya, y'all want to go? Yeah. Oh, I just want to say while we pull up our thing, I'm at the beach this week.
Oh.
Where are you?
We're at Cherry Grove, North Myrtle Beach.
I was going to say, your picture makes me want to be at the beach. I didn't think
I am.
being at the beach.
It's so cold in Boone, so enjoy it.
I am.
I've been
It
cold
was
all
rainy
day.
today, so I don't feel so bad being in.
So yeah, it is interesting district to district.
So what did I miss?
You missed the ed admin group. We just got done.
Oh,
You missed the best presentation so far this semester. Is what you missed, sir.
Yeah. It was amazing. People were enthralled.
I believe so. Oh, cool.
I saw tears of joy flowing from the audience's eyes. They were just so overwhelmed with the quality of that presentation.
Okay, great. Yeah, nice to know. Okay, so are we ready for the next group, or are we doing some deep thinking here?
No, Barbara and I are next. So I will share my screen and get us started. Okay, so as you know, this is our project 3. So we were given 7th grade scores for reading, math, and writing difficulties. So students with difficulties in understanding these reading, math, and writing scores. So the first question that we had for this, and Barbara will go into the other 2, was to identify the students who had at least 1 standard deviation above the mean on reading and 1 standard deviation below the mean on math. So what we did was, we looked through the data for that information. Of course, I didn't collect this data, so I'm not 100% sure about the student IDs, but I think on a normal, like a conference presentation, I don't think the student IDs would be appropriate to put on there. But this is the student that scored at least 1 2/3 above the standard deviation mean for the reading and more than 3/4 below the average score on math. Okay, so I'll let Barbara talk about the other 2 pieces that we had to do for this question.
Okay, everybody. This information talks about the other student who was identified as at least 1 standard deviation above the mean on math and 1 standard deviation below the mean on reading. And this particular student met the criteria for scoring at least 1 standard deviation above the mean, which was a 0.73, and the 1 standard deviation below the mean on reading, which was the negative 1.52. Excuse me. Results means that they scored above the mean for math and below the mean on reading. While the reading score was over 1 standard deviation below the mean, the math score wasn't a full standard deviation above the mean. Next slide, please.
Okay.
So we have this identification, the students who scored at least 1 standard deviation below the mean on math, and of course the 1 standard deviation below the mean on reading. In this case, several students who scored at least 1 standard deviation below the mean on math and reading. From my recollections, about 20 students. One example, whose score was more than 2 3/4 standard deviations below the mean for the reading score, which was a negative 2.81, and scored 1 1/5 below the mean for the math score, which was a negative 1.19. The coding that was used, basically the 0 refers to the Z-scores, and we did this because there was no cases in one group and a small group in another, and it wouldn't have been able to discuss the writing scores based on this information, the specific math difficulty, the specific reading difficulty, and the comorbid.
So, Barbara, can I ask a question? So, like, what does the 0 mean in this case, in this slide?
A 0 refers to the Z-scores.
Oh, okay.
And Kim will just pick up where I left off from here.
Okay. So, so what we did is We have the writing Z-scores for those with reading difficulties. And here are the descriptive statistics. And for those who scored less than average on reading, but greater than average on math, on average, these students also scored less than average on writing. The mean is negative 0.14 for reading Z-scores. There were 126 students who fell into this category. And again, the 0 that we had on our coding represents the Z-scores, and you know, this is the data for that, and the statistical analysis. Schwa, you're making me nervous. You're making me nervous.
You're doing a great job. Don't be.
Okay, and so here we have the writing Z-scores for those with math difficulty. So for those students who scored less than average on math, but greater than average on reading, on average, these students scored higher than average on writing. So the mean is 0.9 for writing Z-scores. There were 167 students who fell within this category. And so for the last test that we were asked to complete were the writing Z-scores for the comorbidity between reading and math difficulties. So for those students who scored less than average on reading and math, on average, also scored less than average on writing. So the mean is negative 0.72. And there were 504 students who fell within this category. So Barbara, do you want to talk about our research findings and also the recommendations?
Sure. Hold on a second. That's our 6 minutes and 30 seconds. I was timing ourselves.
Thank you.
Sure. The students with comorbid reading and math difficulties are also more likely to struggle with writing. Those students who only struggle in reading are also likely to struggle with writing. However, students who only struggle in math are not more likely to struggle in reading as did as well as or better than average. Before I mention the recommendations on how to help students with learning disability profiles, one thing I would like to point out, it was about 21 students who had that combination of the core comorbidity. And I noted for myself, I thought it was interesting, it was 14 male, 7 female, 14 Hispanic, 7 Black. There were some that were coded as far as being in Title I. And from those recommendations, I noticed that the learning disabilities, or we noticed, excuse me, learning disabilities are due to a combination of sufficient assistance to help students. There is a need for tutoring specific groups to give students the ability to adapt to the studies. Students who struggle with both reading and math might also need extra focus on writing. In this particular case, it just happened to be more Hispanic males in this particular group that we had pulled. The students who struggle with only reading might also need to focus on writing. Reading and writing tend to go together, so if a student is struggling in reading, they are more likely to struggle in writing. Students who only struggle with math might do better to have extra focus on math. And so that's one of the things, or several of the things that we've looked at to just from the data. It's really important for us to pay attention to how people, sometimes it's a socioeconomic situation and where people live and how they're grasping, getting the information. Even though this particular percentage to some may be small, I mean, it's still a person is a person. So we need to make sure as educators, administrators, to be able to give them the opportunity to help them to move forward. And that's our end of our presentation.
Yeah, do y'all have any questions?
Fantastic job. Why you were nervous, Kim? You did a fantastic job.
Because you're making me trip up on this.
Sounds like I'm a bad person. So, and Barbara, like excellent summary of the findings. And so one thing I want to mention about is actually maybe just a suggestion. So actually, when you were summarizing the writing profiles of the three types of the students, you can actually merge these three types of students into one table. And you can actually see that their average Z-scores look different. So like the students with comorbid reading and math disabilities, their writing Z-scores might be even like lower than the students who only have reading disabilities, right? So that's perhaps another layer of finding that's worth exploration.
Okay.
I guess one of the questions come into play when you're preparing for a conference or you're doing a presentation. If you're looking at specifics, because people, they look at the whole and they want to see, okay, the breakdown of which specific areas, who are we honing in, who are we addressing?
Mm-hmm.
So that would be my concern too. And I'm sure Kim's.
Yeah, exactly. So, so based on my conference presentation experiences, I feel like, so like if I know that this like a list of tasks is I imposed on you, right? So it's not your like out of your like curiosity or something. But I think the first thing, yeah, you are right, Barbara. You first want to separate the slides and show the characteristics of each type of writers or each type of students. And then if you can make the information comparable, that will be great. And what I meant comparable is like if you can merge the writing performance across the three students together into one table, and people can just eyeball the mean Z-scores of their writing just by looking at that one slide. And I think the audience would appreciate that as well. So this is just my suggestion, and fantastic job. Thank you so much.
Thank you.
Yeah.
Okay, I'll go ahead and share ours. For these disabilities, and so we first looked at several reasons why students would have these disabilities, so family history and genetics, prenatal or neonatal risks, psychological trauma, physical trauma, and environmental exposure. So if you look at math difficulties, you know, one disability that I can think of off the top of my head is dyscalculia. Then for reading disabilities, you might have dyslexia or dysgraphia. And then comorbid disabilities, I'm assuming, are much more extreme learning disabilities, you know, maybe on the strong end of the autism spectrum or something like that. But then there's the background reasons that we listed here for why they might have those disabilities.
And then to Caroline's point about those specific disabilities, you know, the ability to use Z-scores helps us really narrow down our focus. So thinking about reading or math specialists, one, being able to give a more specific diagnosis to some of the disabilities that Caroline mentioned, as well as others, and whether or not it's a more specific specialist, somebody who's more trained and specializing in that specific disability, that specific area. You know, obviously being able to use statistics to really help verify the need for an IEP is really, really important. And really helps with that verification. Same thing with accommodations. I mean, working with teachers to really help narrow the focus of this is why this specific student may have some sort of exceptionality, and what can we do within the classroom, whether it's seating, more time, thinking through interactions or reinforcement, whether it's occupational therapy or something outside of the classroom to augment the student needs, or medication. You know, knowing that there are also potentially chemical or medical needs or challenges which medication could really help balance the students. We know that using Z-scores and really being able to narrow in gives you kind of that first point of entry into a more specific.
Yes, and what really stuck out to us the most is with the writing Z-scores in particular, is that having the reading disability did not create as much of a struggle as having the comorbid disability of both. So clearly that type 3 comorbid math and reading disability is going to require much more support from this list.
You know, and I think too, you know, and again, we're talking to 6 people who know better than we do, but the other thing that really stuck out was just the small sample sizes and how that can be really stigmatizing for those students if, you know, especially knowing that I'm assuming these are mostly invisible disabilities, and how can administrators and educators work to make sure that as accommodations are given, those students aren't stigmatized and their experience is normalized. So just the sample size itself really stuck out to me.
And that's it. Does anybody have any questions?
Good job.
Thanks.
Go.
Yeah,
Another
I
thing off the to-do list.
That's right.
hate to miss I missed the first part of your presentation, but based on what I've heard, you guys did a fantastic job, right? So, and also Tim, a big shout out to you. Last time when I was like listening to your presentation, you were still like, you know, hesitating, but now you are like presenting with confidence. Great job.
Thank you.
And Caroline is awesome as usual.
Feeling good about the Z-scores.
Yeah, great. Cool. So have we finished all the presentations?
We have.
Okay, that's great. So now like your group, yeah, just send me an email with attachment of your slides as a group, okay? And CC your members, okay? And then you can take a break, okay? Right, let me check.
Should we take a break or hang out until the other session's done, just so we don't walk away from the computer?
You can walk away from the computer. I need to check the other breakout room, so that one perhaps is slower. So I plan to come back at 5:20. Okay, so we'll come back to the main room, 5:20. Okay, all right.
This is the second student that we selected, and they were also LEP, and they had a negative 2.68314 of their Z-score at the beginning of the year, and then a negative 1.70602 at the beginning of the year with their Z-score for beginning of the year vocabulary. And we chose these questions based on the fact that they had a garden variety of things that showed up for their disability and their LAP also. So as we said, to what extent are behaviors that might otherwise indicate a learning disability considered to be normal for the child's cultural background or to be part of the process of U.S. acculturation? And how might additional factors, including socioeconomic status, previous education experience, fluency in his or her first language, attitude toward school, attitude toward learning English, and personality attributes impact the student's academic progress? So.
I'm sorry, Corey. I thought we were going to discuss those questions, and I was waiting. So
that's okay.
Sorry about that.
That's fine. Are there any questions about our findings?
So like, sorry, Corey, I missed the first part of your presentation. So like, how many cases did you select for like a deep exploration? Was the was that student, the LEP student, the only case?
We select 2 separate students.
Oh, so could you like briefly summarize what's the situation for the first student? Like
The first
or
student
what-
was at risk for dyslexia.
Mhm.
They had poor decoding skills, and the comprehension was poor, but the vocabulary was at or above average.
Cool. Thank you. Yeah, that was awesome. Thank you.
Yeah.
Right. So have we all finished? Okay, great. So we are gonna come back at 5:20, and when we come back, we will come back to the main room. So after you have finished your final editing of your slides, please send me an email with the attachment of your slides. Okay, and all right, see you soon.
Are we on break till 5:20? Is that what he said?
Yes.
Okay.
5:20.
So Tim, if we do not get an answer from Audrey, maybe we need to just send one straight to Vachel.
Yeah, I'm going to give it another day or so, and then I'll send something.
Will you
Right on.
share if you get an answer that involves no statistics?
No, because I'm upset with you.
Ah!
I'm going to eat dinner.
All right, folks, welcome back. All right, so let's talk about a new concept, okay? Oops, sorry. All right, the topic for today is correlation and regression, okay? Well, this lecture will focus more on correlation than regression, but please note these two are closely related, okay? So, like I requested, please make sure you have your spatial and mathematic reasoning, spatial reasoning and mathematic ability data ready, okay? And I do want to make some notes, okay? So correlation and regression, they are not pure descriptive statistics, okay? Starting from today, we are actually tapping inferential statistics. However, because of my job is to tell you what is descriptive statistics, so I'm not gonna cover what is like p-value or significance or hypothesis testing. Those are Dr. McGee's job, okay? So I'm not gonna take her job, okay? So, and our focus for these two lectures, today's lecture and Wednesday's lecture, are more focusing on the conceptual understanding of the terms, okay? So, but we do need to do some calculation, but SPSS is wonderful enough to do all the calculations for us so that we don't need to memorize any formulas. We don't need to memorize any formulas, but like, you know, for effect sizes, SPSS cannot do any calculation, but for correlation and regression, SPSS is sufficient, okay? All right, and also, perhaps you need to kind of like refresh your mind because we're going to talk about new graphs. We're no longer talking about histograms. We're no longer talking about box plots. We're tapping a new graph, which is called scatter plot. Okay, and we will use scatter plot to visualize correlation and regression. Okay, all right, and okay. And also another set of notes is that chapters 1 to 6 focus on univariate statistics. Okay? Univariate means we deal with one variable at a time, right? Whenever you graph the histograms or a box plot or deal with z-scores, you actually calculate the statistics for one variable at a time, right? So you deal with only one variable at a time. However, starting from today, we need to consider two variables simultaneously, okay? That's the difference between this lecture and your previous lectures. Okay, so we have already simplified some information, but there are still many terms that we need to talk about. In chapter 7, which is the focus today, we're gonna spend a lot of time talking about scatter plots and Pearson-R correlation coefficients. Okay, there's a related term called covariance, and we're not going too deep into it because covariance to me is more like a bridge to Pearson-R. So, but the calculation does convey some interesting information. So we will talk about the formula briefly, okay, but don't be scared, okay? And chapter 8, we'll talk about some other terms that are closely related to regression, such as independent and dependent variable, regression equations. Regression equations, perhaps you have heard of that or kind of tapped that when you were a high schooler, I guess. I don't know about American education that much. So, but when I was a high schooler, I was asked to understand what is an intercept and what is the slope so that I can write out a regression equation. But if you don't have the background knowledge, that's okay because we're going to teach you like step by step how to write out a regression equation. And also you need to use scatter plot again to interpret predicted values, residuals, and based on predicted values and residuals to make a conclusion or make a, or let SPSS to calculate the standard error. The standard error is a term that is gonna be with you throughout this year because all the inferential statistics have something called standard error, okay? And unstandardized and standardized regression coefficients. In your textbook, we only talked about unstandardized coefficients, but it's my job to prepare you better for your next course. So I'm also talking about standardized regression coefficients, but I'm gonna simplify the information. You just need to, I give you examples and you do your homework or do your project based on what I have given you. So I will try to be a good model. So your job is to follow. And okay, so let me get started. All right, so like we addressed just now, like previously we were only dealing with one variable at a time, right? Like when I ask you to calculate the z-score, you calculate the z-score for the first variable first and then for the second variable. But now we're dealing with associations. Associations means two variables need to be considered simultaneously, okay? And at the beginning of chapter 7, the concept of Pearson product moment correlation coefficient is introduced, okay? So Pearson is a dude, is a man, okay? So don't be scared about like this term. Pearson is just a person's name, okay? Pearson's R is, like the R is invented by Pearson, that's it. But the letter R is appearing very frequently in research papers and in conference presentations. And I think for some of you, your dissertation may need to use Pearson R to quantify bivariate linear relationships, okay? So as a literacy teacher, I always talk about the parts in the word, right? So bivariate, if you look closely at that vocabulary, bivariate, you perhaps can think about some other terms like bi-weekly, bilingual, bi-yearly, or even bicycle, right? Those stuff are all related to the number 2, right? So whenever you see a word bivariate, and your reaction would be, oh, okay, they're talking about 2 variables simultaneously, right? And the linear relationship. Okay, folks, I need your background knowledge to help me. I think, you know, based on my, you know, based on the conversation between me and my American folks, I feel like linear is quite a frequent term that is used in daily conversation. But what is linear? Can you tell me what is linear? I'm thinking if you have a term called linear and then you have another term called non-linear, right? So what is linear?
You have that line, or that in the case for statistics, the straight line, and the nonlinear, or it tries to be as a straight line or go in a direction.
You are correct. I saw the answer from the chat box as well. Like you have the consistency of the definition of linear. Linear means straight line, right? So it's straight, okay? It's not a bend over, or it's not like a curve, right? It's straight line, okay? That's great. So Pearson R is dealing with bivariate linear relationships, and Pearson R's job is to quantify it, right? When we say quantify, we mean we use a single value to represent a big thing, right? So Pearson R is actually a single value to quantify bivariate linear relationships, okay? And do you think this is linear? Not at all, right? Right, thank you, Carolyn. Yeah, this is not a linear relationship, but it does exist in research and in daily life. This is what we call a curvilinear relationship, right? It's like a curve linear relationship, okay? So it does appear in research. Why? Because this is actually a real data set. And they are talking about the relationship between the intervention dosage and the student outcome. and the relationship between the intervention dosage and student outcome is curve linear. Why is that? Because, see, I already put a number here, 38 hours. That means when the intervention passed 38 hours, the positive relationship will become negative relationship. The relationship I'm talking about, the instructional dosage and the effect size of the instruction. Okay, at the maximum, it could be 0.80 effect size, and based on your prior knowledge, you know that's a big effect size. But after we have passed the 38 hours, the effect size is going down, right? And so that's why this is curve linear and this is non-linear relationship, because it does not show just one direction. In the same graph, we're showing two different directions, okay? It's complicated enough. So, but fortunately, we are not dealing with curve linear in this class, and not in Dr. McGee's class either. Curve linear is something is actually advanced statistics. So we will not talk about them. But you just need to understand that there's curve linear relationship in educational setting. Okay, and this is linear relationship because we use a straight line to represent the relationship. And also you can see the small dots, the black dots on the graph, right? Those dots are kind of like a cluster together. And I'm just using a line, which we'll learn later is called the best fitting line or regression line, to cut through the dots in order to represent the relationship between the quality and price, right? Quality is the x-axis and the price is the y-axis. Okay, so remember when we plot the histograms, the y-axis is frequency, right? And now when we are dealing with bivariate relationships, the y-axis is another variable. It's not a frequency anymore, okay? And we'll dive deeper into these plots later, okay? All right, and something I think you folks will be happy about is that Pearson R does not only apply to intervally scaled data, it can be applied to any data set, right? As long as you can dummy code it, right? For boys and girls, that's nominal data. You can code them as 1 and 0, and you can do Pearson R correlation, correlate gender with some other variables. And ordinal data like a Likert scale, you can do Pearson R correlation as well. And there are some other types of correlation, such as Spearman's role correlation that you will see in SPSS. However, we will not talk about that in this class. That's still Dr. McGee's job. And the Spearman's role is actually more precisely reflecting ordinal data's relationship. Okay, so just a heads up. Okay, you will learn that in the next semester. Okay, all right, and the two plots that I just showed you, the relation between quality and price, right? As quality increases, the price increases, and the curvilinear relationship between instructional time or intervention dosage and the effect size of the instruction. And you can see, like, we use dots. We use these small dots to represent their relationships. And we have a name for this type of plot. It's called a scatter plot, okay? In research, you can leave a space between these two words, or you can write it like a compound word. So either way, okay? That's not an issue here. Let me see the chat. Yeah, Caroline, you're right, curvilinear, okay? The relation between instruction time and effect size. Scatter plot can do many things. If I follow exactly what your textbook said, it has three functions. First, it visualizes the bivariate relationships. Second, we can use quadrants to determine the magnitude. However, we are not going to tap it because I personally don't think it's quite useful. Third, you can identify outliers of the bivariate relationship. Okay. But if you are interested in this part, I can teach you privately. In SPSS, you can divide your scatter plot into 4 quadrants, right? But that's not covered in this class. Okay. All right. So if you have your data set with you, that will be great. Okay. So, but we need to really understand the steps to create scatter plot. Okay, so how do we create scatter plot? Well, scatter plots, first we need to know that we use scatter plot to visualize how 2 variables co-vary, right? So how they vary together, right? Are they vary like together, or do they have no relationship at all? Okay, that's the function of scatter plot. And then in SPSS, in order to create a scatter plot, you must create ID numbers first. Okay, the beginning of the chapter 7 talked about something called paired scores. Okay, and that's not hard to understand if you already have your ID numbers created. If you have your ID numbers created, you know you need to match the X score and the corresponding Y score to the ID number, and so that you won't mess up the data set. But honestly, this is a true story, folks. One of my, I could call her like friend, she actually gave me a data set, and without any ID number. Without the ID number, if I give a data set like without an ID number to you, you perhaps don't even know how to analyze it because you don't know if the scores are matched, right? So when you collect your dissertation data, this is the step that you must do, okay? All the data set I shared with you all, I have already created ID numbers. I don't know if that's like spoiling you or not, but it's a step like I must do, okay? And after you created the ID number and matched the X and Y score, so like we use X for the variable on the X-axis on the scatter plot, and Y to represent the variable on the Y-axis. Okay, so X and Y. I use X and Y very often. Okay, now you need to open your spatial reasoning and methodability data set. Okay, I put my instruction here. I'm thinking to kind of like flip the instruction. So why not you do this ahead of me? Okay, I tell you what to do. Okay, in SPSS, find your data set. Find your spatial reasoning, which is the X variable, and the mathematical ability, which is the Y variable. And go to chart builder. Are you doing this? Okay, great. Go to chart builder. Okay, you're familiar with the canvas already. This time, do not create any bar charts or histograms or box plots. You double click, I think you can single click the scatter plot. You will see an option called scatter plot. Okay. Double click either the first template or the second template. The second template is a step ahead because it provides the regression line. But the first step will do the job already, okay? Move spatial reasoning to the X-axis and mathematical ability to the Y-axis. And you do not need to change other settings. Just hit OK. give me a thumbs up if you have already finished creating a scatter plot. Great. Kelly already did it. Amanda, Tanya, Chris, Cynthia. Great. Thank you. All right. So I'm gonna. Oops. Oops. All right. Let me open my SPS dataset. Okay. If you did what I just said, you should get something like this. Did you get the same plot as I did? Okay, great job. Okay, if you didn't get the same plot, just feel free to unmute yourself and we can walk you through it. Okay. So
I'm sorry, Dr. Z. I do have a question.
Yes.
I got that, but I guess I went to the, what is it? The
legacy.
The legacy, but then I went back because I would make sure I was doing what you asked. And when I came, I have the same results, but I have the line.
Oh, that's okay. That's the second template of the scatter plot, and that's called a regression line. We were going to talk about it pretty much in the next lecture.
Because I wasn't sure. I was thinking you had said to do the second one, but I guess you said not to do the second one. I just wanted to make sure.
Did you see the dots? Like,
yes, I have the dots, but I also have the lines. So I must have misunderstood when I went back.
No, that's okay. I mean, I think perhaps you use the second template, but that's the same
right.
thing.
I did use the second template, and
yeah,
I just want to make sure I
right.
did
yeah.
it right.
So I will use for your next lecture, I will use this plot for illustration, for explanation. Okay. So, and now let's focus on this type of plot because this is the first step, right? So, and we created a scatter plot. And how do we look at it, right? And this is simply a scan page based on your textbook. Okay, you will see the same figure on your textbook. Okay, all right. So each dot, the first information you need to understand is that each dot is representing a real person, and that person is from your data set. It's not a hypothetical, or it's not imagined person. It's the real person from your data set. Okay, for example, for student number whose ID number is 12, the paired scores is spatial reasoning is 50 and mathematical ability is 70, right? If you're looking at this. And for another student number 1, the mathematical ability is 133 and the spatial reasoning is 85, okay? And you can and from this plot, based on the trend, you can pretty much see that the scores are kind of clustered together and they are facing one direction, right? That direction from here to here, that's one single direction. So we are sure that there's no curvilinear relationship, right? Because that's just the one direction, and there's no bend at the middle of somewhere, right? This is just the one direction. So this is a linear relationship, right? And second, you can see that when the spatial reasoning is quite low, the mathematical ability is quite low as well, right? So the 50 is perhaps the lowest the spatial reasoning score, and 70 is also one of the lowest mathematic ability score, right? But let's see, with spatial reasoning goes up, let's see, a 55. If a student got a 55, this person perhaps is like a 54 or something. And if this person got, sorry, if this student got a 54 and his mathematical ability is around like 89 or something, right? And then another student got a spatial reasoning of 57 or 58, and his mathematical ability is also increasing, right? His mathematical ability is around 100, right? And yes.
I'm sorry, I didn't mean to interrupt. Does Tanya answered my question for me. If you go to elements and data labels, you can choose it to show the student number. I was going to ask, how do you, when I'm looking at it, how do you figure that out?
Yeah, thank you, Tanya. Yeah, that's a great strategy. Okay. Great. So, and when you actually, so basically what I'm talking about here is based on this trend, we can see that as spatial reasoning increases, mathematical ability also increases, right? Did you see that trend? When the spatial reasoning is quite low, the mathematical ability is low. When the spatial reasoning is mediocre, the mathematical ability is also kind of mediocre, right? And for this student, he got a spatial reasoning really high, 85. If you transform it into z-score, that's perhaps 1.5 standard deviations above the mean. And 133 on the mathematical ability, that's way above the mean, right? So this is showing that the spatial reasoning can pretty much predict mathematical ability, right? And that relationship is positive, right? However, do we have an outlier? When we talk about outlier in the scatter plot, that has a different meaning from the outlier in the box plot, right? You know, on the box plot, we're pretty much seeing like the extreme scores, whether it's extremely high or extremely low. But an outlier on a scatter plot is more like a student or a dot that doesn't really follow the trend, right? You can see this student and is kind of like, is actually staying away from the flock, right? So like the majority of his peers are like clustered in this way, but this student number 26 is here. How do I interpret this? Well, although the majority of the students, based on the trend, we can see as spatial reasoning increases, the mathematical ability increases. We do have an outlier in this scatter plot. And how do we interpret the outlier? The student number 26, x equals to 86. 86 is well above the mean on spatial reasoning. But look at his mathematical ability. 76. 76 on the mathematical ability test is way below the mean of mathematical ability, right? So this is the outlier on the scatter plot, okay? Any questions before we move on? Okay, seems everybody's getting it, okay? Great. Okay, so we're not done with the scatter plot yet because I need to make sure you understand it completely, okay? And there are three characteristics of the relationship as reflected by scatter plots. Okay, first is direction, positive versus negative, okay? So far I have only shown the positive relationships, but in the next slide, I'm gonna let you interpret negative relationships, okay? And the second characteristic is the form, linear versus non-linear, right? Remember the first two examples I showed you at the beginning of this lecture, right? We do have non-linear or curved linear relationship. That's the synonym, right? Non-linear equals to curved linear relationship. Okay, Unfortunately, we are not dealing with nonlinear relationship in statistical analysis in this course, okay? And the degree, strength of association, okay? So strength of association is pretty much determined by how well the scores are clustered together, right? So you can see some of the scores are pretty much like, you know, they're not clustered, they're pretty much everywhere on the scatter plot. And that's not a strong association, okay? But the example here, they are pretty much close to each other, right? So I can see that their relationship is at least medium, right? So that's my judgment, okay? So that's the three characteristics of the relationship. And I'm gonna give you some more examples and give you opportunities to practice, okay? So the first thing I need to show you is the more examples, okay? So here are 4 different scatter plots without a regression line, okay? So you should eyeball the relationship by just looking at the 4. First, positive relationship. And you can imagine this is mathematic and this is a relation between spatial reasoning and mathematics skill, okay? Positive, as one increases, another skill also increases, okay? And this is negative relationship. A negative relationship is when the X score increases, the Y score decreases, right? That's, you just need to kind of like, you know, reverse the relationship. But it's quite strong relationship, right? Because they are still clustered together. And the linear relationship, you can see like this relation, this scatter plot, the third plot that I'm looking at, I don't feel like is having as strong relationship as the first one does, but it's still showing just one direction, right? So it's still a linear relationship, okay? It becomes more apparent when you make comparison between these 2 graphs, right? This one, on a one single scatter plot, it has 2 directions. First, it is facing this way, and then after a certain point of X, it is actually facing downwards, right? So this is called a curvilinear relationship, right? Okay, any questions before we move on? Oh, by the way, I think I need to talk to you about like the degree is actually, as a concept or strength of association, is independent from direction. So you can have a positive strong relation. You can have a positive weak relation. You can also have a negative strong relation. You can also have a negative weak relation. So this concept, the strength of association, is independent with direction, right? So that's 2 different characteristics. Okay, I'm gonna let you tell me. Okay, this is our first practice in this class, and now I want you to tell me, by just looking at the graph A, how do you interpret the relation between temperature and beer sales or amount of beer sold? How do you put it into statement? How do you say it? How do you describe it based on the scatter plot? And I see some chatting. Great. Yeah, so put into this context, yeah, many of you got it right. It's positive, right? So put into this context, how do you describe this relationship? Yeah, Tammy got you put the harder the better. So like, can you be more precise? Like, what is better? I love to see your interpretation. Okay, so it's quite interesting. The hotter the temperature, the more beer sales occur. Yeah, Kelly, that's perfect. Okay. Yeah, the majority of you got it correct. Correct. So, yeah, but from this chart, I don't see any summertime, right? So, yeah, it's quite interesting. What kind of beer? I don't know. All right, so now I want you to interpret the second scatter plot. The x-axis is still representing temperature, but the y-axis has changed. How do you interpret the second relation, the second scatter plot? It's negative, it's linear. And how do you interpret in this context? Based on the name of these two variables and use your background knowledge. Yeah, great. Yeah, that's great. Yeah, you all got it correct, okay. Caroline, are you a big Starbucks fan? Good. Right, so the negative relation here shows that as the temperature increases, the amount of beer sold decreases, right? And for graph A, as the temperature increases, the amount of beer sold increases. Okay, simple as is. Okay. So in your final exam or in your participation question set 4, I want you to use the language as simple as it is. Okay, so you don't have to give me an essay talking about their relationships, and I don't need the theory about like a Starbucks or like or the beer brand or something. But yeah, just to put simple statements. All right. Okay, here's your another assessment. Which association is the strongest? A or B or C or D? I'm only asking the degree of relationship, okay? Which association is the strongest? There's only one correct answer. If that can help. Okay, if you put C, and you are correct. And so the graph C is showing a perfect negative relationship because all the dots are on the same single line, okay? And what is the second strongest association? A or B or D? Second strongest. If you put A, that's correct, okay? And which one is the weakest? You guys are on it, oh my God. I think after 1 year, you will be my teacher in stats. Right, great. Okay, now I want you to download the participation question set 4 and work on the first 2 questions, okay? And I'm gonna give you, excuse me, around 8 minutes, okay? You perhaps need some time to build a scatter plots. Okay, the participation question set 4 is on As You Learn. Okay, this is the task description and this is the data set. Gonna download it. Oops, are you serious? You can do this ahead of me, okay? So I'm just playing around with my screen. So download your tasks and to read the first 2 questions. Okay. Create three scatter plots. You just need to copy the scatter plots to the Microsoft Word. Okay, let me know if you have any questions. Okay, should be quite straightforward. All right, how did it go? Do you have any problems? I see a thumbs up by Kelly, and it seems like everybody is doing great. Okay, thank you, Amanda, Chris. And all right, great. So now, how do you like the pace today? Like, am I going too fast or like too slow, or it's good? Okay, all right, thank you. All right, thank you for the feedback. Perfect, thanks. All right, so now we are moving on to the next part, okay? So we have a scatter plot, which is cool, which is great. However, many times we want a specific number that tells us what is the overall relationship rather than just the guessing around, right? The scatter plot can pretty much give us like, can pretty much let us eyeball the magnitude and the direction, and also linear versus non-linear, which is cool. But because we're precise researchers, we wanted to make sure everything is precise. So we need a single number, a single value that shows the overall strength and direction. Okay, because we want that value to show the strength and the direction. So that value has to be specific, and that direction has to be reflected by a positive sign or a negative sign. A positive sign shows positive relation, and negative sign reflects a negative relation. Covariance is covariance is one of the measures to precisely show the relationship between two variables. Okay. The formula looks a little bit complicated, and I'm not gonna dive deeper into the formula or the calculation process. I will just present. However, what I want you to do is give me some answers. Okay, I need to see some typing going on. Okay, you learn a concept related to, not related, a concept that's reflecting x minus x bar, y minus y bar. What is it? What it is? What is it? X minus x bar, y minus y bar. I wonder what it is. What this is? Is this like? Can we use a term to describe x minus x bar? Yeah, you are pretty much getting close. But x value minus the mean. Yeah, x bar is the mean of x. Caroline, you are so close, but you typed an actual word. The deviation score, right? Oh, Tim, you are on fire tonight. Oh my God. Okay. Deviation score. Okay, so we are pretty much reflecting. So if you look at the numerator of this formula, you can pretty much see that like this is the x minus x bar is the deviation scores for the x variable, and y minus y bar is the deviation scores, is a list of deviation scores for the y variable. And we sum them up divided by n. N is the sample size, right? So with this formula, we know that the covariance, although this formula looks so complicated, but we know it provides some measure to reflect the level of like how much they co-vary, how much two variables co-vary, right? Okay, so this is the calculation process that you can do it in SPSS. Okay, so based on the formula, you need to know x minus x bar first, and here's a list of deviation scores for x. And y minus y bar, here's the deviation scores for y. Y is mathematical ability, right? And we just need to do some, you know, elementary level multiplication, right? So, and we got the product of the two deviation scores. And we have a list of the products, right? And based on the numerator, we just need to sum it up, and we got plus 2806, and that's the numerator. And based on the formula, we use that numerator. We divide that numerator by the sample size. Sample size is 30, and we get this value. And this value is covariance. Okay, all right. Okay, however, there are some problems with covariance. Okay, so this is, you just calculated, I just showed you how to calculate the covariance, and which is plus 93.83 for math and spatial reasoning. And for educational administration folks, you analyze the teacher knowledge data, although you didn't analyze the association, but I did that for you. So the relation between the phonology and the non-phonology items, if we use covariance to reflect that, that magnitude is plus 4.93. And for higher ed folks, you analyze the reading scaled and the writing scaled data. And guess what? The covariance of these two variables is plus 45,000. That's a huge number, right? So folks, tell me, what kind of problems did you see if we use covariance to describe magnitude of the relationship? Those are real numbers, right? I didn't make it up. I did my homework. I calculated the covariance.
Well, it depends on the relationship. I mean, as far as something being stronger, because you have limitations.
Mm-hmm.
The magnitude of the covariance is dependent on the underlying scales or the metrics or the variables involved.
Wow.
But
you are on it. Great.
You know, I'm still scratching my head when you talked about higher ed, so I have to figure that one out.
Great. Yeah. So like your explanation is absolutely correct. Yeah. So we do have a couple of problems, and not just the measurement part. Yeah, there's no scale to compare it to. Caroline, you're definitely correct. Okay. All right. So we do have 3 problems if we only use covariance to represent the data. The first is just like variance, right? You did calculate variance when you were struggling to find effect sizes, right? It's like variance, covariance can also get too big, right? Like the reading scale and writing scale data can get 45,000. And like Barbara said, that's because how it was measured or how the data were reflected, right? And second, covariance does not have a range limit, right? Does not have a like a standard scale, like Caroline said. So we cannot really make any comparisons, right? You can't really take 45,000 as a value to compare it to any other covariances, because it's just it doesn't make sense, right? And the third, if you look at the formula, actually it does not, yeah, let me show you this. Okay, sorry to go back and forth. We did calculate the standard deviation, but the calculation process of the covariance did not really consider the standard deviation for X or the standard deviation for Y. Okay, so that leads to the third problem. The covariance does not consider variability within each variable. And that's a legitimate issue, and which makes our estimation not precise if we only use covariance to represent the magnitude. Okay, therefore, here is our main character for tonight, Pearson R. This is why Pearson R is invented. Okay, we need to standardize the covariance, and when we standardize it, we get a Pearson R. When I say standardize it, you need to understand that I'm talking about that standard deviations will play a role in the calculation process. Let me show you this. Okay, I translated the mathematical language into English so that you can understand it better. But actually, the numerator for correlation for Pearson R, the numerator is actually the covariance, right? This is the covariance. I put it on the numerator. This is covariance divided by, we're considering the variability now, right? Divided the x multiplied by sy, and those are this is the product of two standard deviations, right? The standard deviation of x times standard deviation of y, okay? And to translate the mathematical language into English, the numerator is the degree to which x and y co-vary, right? This is called covariance. And the denominator is the degree to which x and y vary separately, right? This is the what we call the mathematical reasoning, right? So this is how we interpret the Pearson R, okay? And no matter how big your data is, no matter if you use scaled data or raw data, the range of Pearson R is from -1 to +1. Woohoo. That is huge. That means we can do some comparisons, right? That's why Pearson R is so popular. Okay. All right, so there are some explanations and there are some rules of thumb for Pearson R. And first we need to acknowledge that this scholar has done a fantastic job to minimize the range, right? So that we can do some comparisons, right? And so that what we talk about on this slide makes sense, right? The range from -1 to +1. -1 would mean perfect negative relation. And +1 means perfect positive relationship, okay? And zero means no relationship at all, okay? And there are some rules of thumb, and this is different from effect sizes, right? Effect sizes, like we talk about 0.2, 0.5, and 0.8, and for Pearson R, we have different rules of thumb. If you get a Pearson R of 0.7 or greater, you will see that there's a strong relationship. And if you get a Pearson R ranging from 0.3 to 0.7, you will see that's moderate. And if you get a Pearson R less than 0.3, you will see that's a weak relationship. Okay. All right. Any questions before we move on? Good. All right. So how do we let SPSS do? Because we don't want to do the calculation, and the SPSS can do it for us, right? And we always use SPSS to analyze the Pearson R, and we format it based on APA requirements, and we put it into our manuscript for dissertation or for our research publications. Correlation matrix is ubiquitous in research papers, and I'm gonna dive deeper into this. Okay, this is the correlation matrix that I made based on higher education people's data. Okay, so this is the relation among reading, math, and writing. Okay, so like in SPSS, they will ask you if you want to flag significance, and you don't have to understand what a significance means, but for your future assignments in this course, you just need to format your correlation matrix in this way. Okay, why we are making Pearson R, like, why we are making a matrix using Pearson R? Because many times we're not just dealing with two variables, right? We have to talk about the bivariate association among a set of variables. And when you collect your data, you will perhaps collect 5 or 6 or 7 or 8 variables, and you perhaps want to know the correlation between each pair, right? So a correlation matrix is realizing it. Look how beautiful it is. And also, like, folks, let me ask you this, okay? So in this matrix, what I'm interpreting is, okay, I'm listing 1 as reading, 2 as math, and 3 as writing. And this 1 will refer to the reading, and 2 refers to math, and 3 refers to writing. Okay, so that in APA, I don't have to really say reading, math, and writing again because I already did it for the column part, okay? But why I'm not printing this relationship? Why I'm not talking about the relation between math and reading here? Why this is blank? Normally, I should have another value here, right? So because 1 is reading, 2 is math, I should print something here. Why I didn't do that? Did I make a mistake? Should I commit suicide for that? My question was why I don't put the relation between 2 and 1 here. If you can see my cursor. It's already there. Thank you, Carolyn. Okay, so if I want to find the relationship between reading and math, I already have this already, 0.09. I have this already. And so I don't have to print it at the lower diagonal again, or the upper, sorry, I don't have to print it on the upper diagonal again because I already have the same value. So if you understand diagonal relationship, you will see like this one will be mirrored here. But in APA, we don't print repetitive information, right? Same thing here. The relation between math and writing, 3 is writing, right? The relation between math and writing, we don't need to say it again here because we already have that. 2 and 3 is 0.05, okay? This is how you do it in APA, okay? And now this is your challenge, okay? So this is a correlation matrix from a real research paper, okay? And you don't need to understand too much about the background information. And this is because I'm gonna introduce to you, okay? The correlation matrix is showing the correlation between 17 variables related to teacher, and one variable is called student externalizing behavior. And when we translate it into common language, it's called the frequency of students' aggressive behavior, okay? So this is the relation between teacher variables. You can see like TSE is teacher's student specific self-efficacy, and their relation with externalizing behavior, okay? And I know this is overwhelming. The information here is overwhelming, okay? But I want you to just look at the 2 variables. First is the 7th variable, the teacher self-efficacy on behavioral management, and the first variable, which is externalizing behavior. Okay, look at this statement and tell me what is the Pearson R. If you have trouble seeing it, I can click on this. If you have your lecture notes with you, you can do this with me, okay? So you can, this is a published paper. And I'm asking you, what's the relation between the 7th variable and the first variable, or the teacher's self-efficacy in behavioral management and the frequency of externalizing behavior. What's the Pearson R between a 7 and 1? 1 is externalizing behavior. Yeah, the magnitude was correct if you put minus 0.74, okay? Make sure you put a minus sign, okay? Because this relationship is negative. And now here's your challenge, okay? So based on the information, so you don't have to have, you just need to understand this is teacher self-efficacy in behavioral management. BM is behavior management. And number 1, externalizing behavior is the frequency of aggression, okay? Student aggressive behavior. So what does this negative relation tell you? How do you interpret it? How do you explain, based on your knowledge, how do you interpret a negative Pearson R of minus 0.74?
Does that mean that forget it? No, does that mean the more I'm trying to understand student specific self-efficacy.
Yeah.
Does that mean? Mm-hmm. Does that mean the? I'm struggling to.
That's okay. I know it's Yeah, Caroline, you are absolutely close. Unless I think like the variable on the y-axis is actually the externalizing behavior or the frequency of aggressive behavior. Okay. So yeah, Caroline, you are getting very close. So the correct way to interpret is first 0.74, negative 0.74. Is that a strong relationship, moderate relationship? Or yeah, Karen, you are right. Okay, there was a strong negative linear relationship between these two variables, right? First, then you need to explain the magnitude, right? And second, yeah, and I'm just gonna repeat what Caroline already said in the chat box. Okay, the higher the self-efficacy is, the lower frequency of the student's aggressive behavior. Okay. The higher.
So, okay, so where does, when I looked at, everyone was putting negative 0.74, I was looking at the relationship of externalizing behavior, which was number 1. Before I looked down at number 7, the TSC for BMT1, I looked across for the 1. That's what I was looking for, the 7th position, across to the right. So help me understand, is this supposed to be it's a table, but is it supposed to be Y graph, X graph? How am I supposed
to? No, it is a matrix. So this is like how do I interpret this? Guys, help me. So like when solving a matrix problem, right? Like many times it's more like a matching game, right? So we find the first is externalizing behavior, right? So the number 1 is always representing externalizing behavior. So if I want to find the relation between the first variable and the 7th variable, we just need to find the first variable first. Okay, this is the first variable, and we just look down. We just need to look down and locate where the 7th variable is. Okay, this is perhaps is called like a cross point or something, or an intersection, if you will. 7.
I think that I'm not trying, Barbara, I'm not trying to speak for what you asked. I think the question is there's just from a semantics perspective,
Okay.
the horizontal descriptor versus the vertical descriptor. So when you're talking about the 7th variable, you're talking here about the vertical descriptors. Is there a different descriptor for the horizontal numbers in the matrix? So when you're talking about a variable, we know to look horizontal, or we know to look vertically instead of horizontal.
Like when you say horizontal, did you
Correct.
mean 1, 2, 3, 4? So like you can see like this exactly the same with the vertical, right? There are 17 variables on the horizontal.
Okay.
And there are 17 variables on the vertical column, right? So 17, 17. So 1 matches 1, 2 matches 2,
right,
3 matches 3. And if you look at the this relationship, right, 1.0, that means the correlation between externalizing behavior and externalizing behavior is 1.0. Of course, right? This is like correlating with itself, right? And 2 with 2, closeness with closeness, and 17, the student age with student age, 1.0. That's perfect relationship. So
okay, then explain to me, because I initially looked at this at the number 7 space, TSC for BMI T1, and I went all the way across to the 1.0, thinking that externalizing behavior at the top. And that's why I was looking at the commonality or the repetitiveness. That's what I was misinterpreting. Do you see where your arrow is right there? That's what I put the number 7 as far as going to the top, but that's not correct. So I was trying to understand as far as me trying to interpret the proper.
Oh, Barbara, like, yeah. So actually if you are looking at 1.0, that means that is actually reflecting the relationship between the 7th variable and the 7th variable.
Gotcha. I understand now. Thank you.
Thank you. Great question. Okay. All right. So if in the final exam, I give you an authentic correlation matrix like this, and I want you to interpret the relationship to me, do you feel confident to do this?
Well, again, I think this question I had for you before in the office, as far as the wording, the breaking it down in English, a correct way to say it or a simple way to say it.
A simple way to say it is just if we're talking about, like, I think you can use something called like a formula or strategy here. For example, like when we talk about negative relationship, okay, and when we talk about negative relationship, the English phrase will always be with one increases, another decreases, right? That's the negative relationship. Barbara, are you with me or?
Yes, I'm writing it down. We refer to negative relationship when one increases or one decreases, the other increases, it's like the seesaw effect.
Yeah. Oh, perfect. Perfect analogy. Okay. So yeah, with positive relationship is as one increases, another one also increases, right?
Right. So we have this this answer here, or this when you ask the question regarding externalizing behavior, which is the first one, and I'm looking down to the 7th position based on the teacher-specific self-efficacy, and it has a negative 0.74. The English translation would be of something is negative and something is positive. I just want to understand how am I to write it to make sense.
Yeah, and when you know how to express negative relationships, and then you are gonna apply that formula into the context, right? The context here is teacher self-efficacy and student externalizing behavior. The higher the higher the teacher's self-efficacy is, the lower externalizing behavior is. But the lower doesn't make sense if you don't understand the measurement, right? So the measurement is frequency. We use frequency to represent the degree of externalizing behavior. So so when I rearrange my phrases, I can say something like, the higher a teacher's self-efficacy is, the lower frequency the student will show aggressive behavior or externalizing behavior in the classroom. Okay.
Repeat that again, please. I'm writing this down.
Okay, so excuse me. So first, the student's externalizing behavior in this context is measured by the frequency of aggressive behavior in the classroom. Okay, that's the background knowledge. Okay, in the exam, I will provide it to you. Okay, and then because there's a strong negative relationship, first I want to say there's a strong negative relationship, and then I will say that this strong negative relationship is telling me that the higher the teacher self-efficacy is, the lower frequency the student's externalizing behavior is, or the lower frequency, or you can see the lower chance, like whatever it is suitable for your expression.
Again, the higher the teacher's self-efficacy, the lower the student's chance for externalizing behavior.
Mm-hmm.
Okay.
Exactly. Yeah, that's a negative relationship. Yeah. For this problem, perhaps it's a little bit awkward because there are a lot of mouthful words, but I will make sure I will use some simple context for your final examination. Okay. All right. Any questions before we move on?
I have another question.
Yes.
Based on, I think it's similar to what I think Tim was alluding to earlier. So when I'm looking at a pattern like this, regardless of what it is, this matrix, I should utilize the X factor, in a sense, the X axis, and then put the Y axis afterwards? Or does that make a difference?
Wow, that's a great question. That's a great question. Yeah, so folks, in conventions, okay, I'm talking about conventions. We talk about the X variables first, and then talk about the Y variable. Okay, so when we describe bivariate relationships, we will always, for this example, teacher efficacy will be my X variable, and the student externalizing behavior will be my Y variable. So just like what Barbara said, I will describe my X first, and then talk about how Y varies based on X. Okay, so talk about your X first, and then your Y. Does it make sense? Okay, great. Yeah, I think my strategy is always draw a X and Y matrix, like a simple thing like this, right? So you put X variable here on the X axis and the Y variable on the Y axis. So that can help you a lot, right? For interpretation. Okay, now, right, do we feel good about it? Let me see the chat. Great. Yeah, correlation matrix is a skill that you need to master before you move forward, okay? So for your participation questions and final project, oh yeah, your final project, that will involve a large amount of variables, okay? For higher education folks and educational administration folks, your data set has changed. So, which is interesting, okay? And you are dealing with 5 to 7 variables simultaneously. And you need to create a matrix like this and also interpret it.
So you mentioned there's a way to do this in SPSS?
Oh yeah, let me show you. Okay, so now folks, let's work on question 1C. And question 1C is actually asking you to create a correlation matrix. Okay, we practice right now. And this is our last slide tonight. And we still have some time to solve some common problems. Okay, let's see the question 1C first. Oops, going too far, sorry. So you have 5 variables in that hypothetical data set. And what I want you to do is to create a correlation matrix with the following 5 variables. And you need to format it based on the APA format, which means you can only have one diagonal, okay? Do not put both diagonals, right? And also you need to put a title to your table, okay? I'm gonna show you, I'm gonna use a different data set to show you how to do it, okay? So that I'm not doing this for you. I think I can use project 1 dataset. I go to analyze. I go to correlate. Excuse me. I go to correlate. I go to bivariate. Okay, I'm staying on this screen for 2 seconds. Correlate, bivariate, and I click. Okay, so it will be perfect if you can work on your participation question data set simultaneously with me. My data set will be different. And you are gonna highlight all the variables. Okay, my situation is different. I only have 3. And you have 5. Okay, in your case, you move all the 5 variables to this variable box or list or what have you. And it is optional whether you check this box or not. Okay, we are not going to talk about significance. Okay, and you go to those are optional. Okay, we talked about covariance, but I don't really want you to calculate them. Okay, so you just click OK, and you will see like a lot of information, right? You will see the sample size, you will see the significance, and you will see the Pearson correlation. But in order to format, and also like you can see the numbers on both diagonals. So in order to
question, Dr. Z.
Yes.
You on your chart, you had there was a two-tailed underneath the
that's also related to significance, statistical significance. That's inferential statistic, and we are not going to address that.
Okay, I just wanted to make sure.
Yeah, thank you. Great question. Okay, and so you kind of like just copy it and to a Word document, and you paste it. Oops. I think I prefer paste special. No, that's not gonna make any difference. Okay, so I think it's a little bit messed up, but let's see. Yeah, it's messed up because when I copy it, I perhaps didn't really. Try to see if there's a simple way to do it, but never mind. And the first thing I need to do is just delete not useful information. The significance and the sample size, we do not need them for the correlation matrix. Okay.
Dr. Z?
Yes.
I don't know why sometimes it will not allow you to copy the NSPSS. At times it works perfectly, and then at times I have to use the Shift Command 4 and kind of take a picture, not a screenshot necessarily, but highlight the table and then just drag that over, but it's
Oh.
it's strange how it comes and goes.
Penny, can you try double click? Like,
Yeah, I've done that too.
and can you try like just select the whole table? Can you like just like hold your mouse and or
Yep.
like you know like you can drag it and right click on it
Okay.
and hit copy.
Yeah, it copied, but it doesn't copy in the table format. It just kind of runs it all together.
Right. I think I'm having the same issue here. Like, yeah, but you know, we are researchers, so we can create some magic, right? And we just need to make sure like they are matching with each other. So like when you are actually formatting it, you can actually number them like a professional correlation matrix would do. Okay? And you can also rename it, but I will do this later. Okay. And this is 1, and this is 2, and this is 3. Okay, make sure you understand what I'm doing here, okay?
So just to be clear, we should be taking out the N and the significance two-tailed.
You don't have to. If you like, oh, sorry, like, are you asking oh, here, yeah. So for the correlation matrix, we don't usually print these two right underneath the
Right.
correlation. So we just need the correlation.
Right.
Pearson correlation. Okay. And I just need one diagonal. And I don't need this node because in this course, you don't have to deal with you don't have to deal with significance. Okay. But you can like leave the flags there if you prefer to do that. Okay, I'm gonna leave 2 decimal places for everything. Okay, 1.00 and 0.71, sorry, 70, and this is 0.73.
As we're getting used to deleting the redundant data, is it too simplistic to say the 1 is essentially a border and everything on the other side goes?
Kind of. So was that a question or like a comment?
I think it was a little bit of both.
So can you repeat your question?
I just, as I'm looking at what you're doing and what I'm doing, and trying to remember what to delete in order to avoid redundant data, it just hit me that essentially anything to the right of the 1 you delete, if that makes sense.
Yeah. Yeah, so like for me, I'm not as smart as you, Tim. I just sometimes
Stop with your patronizing.
I just like format everything based on I'm a rule follower, if you will. So I know like APA format asking me to just leave one diagonal there, and I just follow the rules. Okay. And I need to put a title. And also, you know what? My favorite font is Times New Roman. And your APA 7th edition also tells you to use Times New Roman. Okay. And I can put a table 1, and I put a title here. Correlations among reading, math, and writing. Okay. And it flags the significance, but you don't really have to do anything with it. But just like a heads up to your next course, many times we say like, you know, this is P. Okay, oops, sorry. But you don't have to do this. Okay, I'm just playing around with formatting. Okay. All right. So like. And when you do a PowerPoint presentation, you can pretty much just take a snapshot and paste it back. Does it look beautiful? I guess it is. Oh, sorry. Based on APA, actually, I have to italicize the title. oops, sorry, I need to take a snapshot. Okay, and your participation question, I want you to do something like this, and it looks a lot like this published article, right? But if you have no idea of like p-values or the flags of the significance, you just you can pretty much delete everything here, right? You can delete them. If you delete them, also remove your note. Okay, make everything, make all the information in your table consistent. Okay. All right. Yeah, Candy, I use like the snaping tool when I was a Windows user as well. So I think there's a shortcut like on your keyboard, if you will, to take a snapshot. So how are we doing? Good?
I may have similar, just a little glitch, I think, similar to what Penny was alluding to. I copied my information into a Word document or to that Word document, but I'm not getting the table. So I'm having to go back or try to go back and either try to take a snapshot or find update some more software, because I end up having to make it run a little bit faster today. So it's just a matter of the table.
Yeah, I didn't take a snapshot at this step. I simply copied everything and pasted it to Microsoft Word. But initially, the format was messed up. But I managed to just format everything based on APA, right? Okay. So APA rule is quite simple to master for correlation matrix, right? So you just need to print one diagonal and number your variables. And for your case, I think you should have a 1, 2, 3, 4, 5, right? And you should have a diagonal like this, right? So 1, 2, 3, 4, 5, and you should have 1, 1, 1, 1, 1, and you should have like other correlation coefficients here. Okay. And the thing is, like, based on this information, you need to understand how to interpret them. Okay. So that's more important. Remember, to interpret the Pearson R, you use rules of thumb, and also look at the 3 characteristics that we just shared about. But we don't have a nonlinear relationship in the data that I gave you. So you pretty much just focus on the first and the third characteristic. Okay. All right. Oh, thank you, Candy. I didn't know that. Candy, can you show us how to do it? So like, well, you can actually delete the information within SPSS, Was that what you said?
Yeah, you can make most of the changes in it. That's it's a lot of playing around, trial and error.
Oh, wow. See? Oh my God. That's really helpful.
Yeah, there you go. If you click on it, then you can delete that stuff. And then I use the snipping tool to take it over.
Oh my God. I love that. Huh, cool. I don't know why the flag is there, but I pretty much can, yeah, maybe I can let them not flag the significant relationship at the, that's fine. I will follow your suggestion, like use a snipping tool or something. Yeah, but remember you do need to format it. Okay, so like if it doesn't give you the 1, 2, 3, 4, 5, you need to number them. I think you can do this with the SPSS, I guess. Yeah, I can do that. Woohoo. Oh my God. I think the snipping tool is more for the Windows users. Yeah, so, but for Mac users, I think snipping tool is also like a snapshot tool, right? So like Mac users, you just need to, hold Shift and Command and the number 4 on your keyboard together. Shift, Command, and 4. And it will let you grab something. All right, so seems like everybody feels good about today's content, okay? And remember, you still have another lecture, which is ready for you to study. And if you are still energetic, you can do this tonight. Right, Tim? You want to do this tonight? Start another lecture?
It's an option.
Okay. All right. So I don't know what happens to the voice thread. The voice thread doesn't allow me to upload the lecture, but which is good because on YouTube I can put subtitles on. So like if you're not used to my accent, you can actually just click on the subtitles and it will show you all the transcriptions. And I did some editing already, so I already made sure all the subtitles are correct and precise. Okay, so I think this is a plus for YouTube. Okay, that's your module 10. So don't be scared about the time limit, or I mean the length of the video, because I did show you step by step. Maybe not step by step, but did give you like some instruction on how to solve the part 2 of the participation question. So make sure you follow my instruction, and also for your project. Okay, you can see that this time, oh, this is your final project. Congratulations, folks. Okay, and education administration and the higher ed folks, you will use the same data set. And also because this is the final project, and Dr. Z is more like a control freak, always give you a list of tasks and let you analyze the data. But now I want you to tell me what you want to analyze. Okay, I give you like maybe 80% of the autonomy, if you will. So like for our friends in the educational administration and higher education, the 10 I think we have 10 people, right? 10 people, 10 of you will use a brand new data set called teacher job satisfaction, okay? You will not be dealing with like a phonology, non-phonology, reading, writing. You will just be dealing with teacher satisfaction. And if you download this data set, okay, so, oh, by the way, like I do have some background information to give to you, but you don't need to dive too deep into the information. You just need to understand the background. But this page will give you all the necessary information you need for analyzing this data, okay? So when you download the data, oops, where am I? Yeah. This is like a teacher satisfaction data in USA. Actually, I have 20 plus countries teacher satisfaction data, and I'm gonna share some of them with Dr. McGee so that if you're interested in that, you can actually analyze them. And if you go to variable view, it gives like the full name of each variable, okay? And you are gonna tell me which variables you are more interested in creating a correlation matrix. And after you listen to the module 10's lecture, you are gonna analyze, you are gonna find a dependent variable and then analyze the predictive power of each independent variable. But folks, although chapter 8 is actually talking about the simple linear regression, and but when you analyze your project data, I'm actually asking you to do multiple regression, okay? So, but you just need to follow my instruction and interpret the standardized regression coefficients, and that's it. So you don't need to worry about other stuff, okay? All right, follow my lecture, and for educational administration and higher ed folks, your data, your data is common, okay? But I think you will have different research questions. Okay.
Dr. Z, I just want to make sure this last project is still a group project or is it individual?
Group project.
Okay.
So you still work with your partner, and this is the last chance to collaborate with your group partners. So seize it. All right. All right, and another thing I do want to talk to you about. Oh, yeah, I forgot about our literacy folks, right? For literacy folks, your data set remain unchanged. You will be still using the data set that I give to you. But to be less control freak, I give you all the autonomy, and you need to tell me which variables you're interested in. Create a correlation matrix and analyze the regression coefficients, okay? If you have any interested, if you have any, for example, like any confusion about these tasks, I still have office hours on Thursday from 4 to 6 and Friday from 1:30 to 4, okay? All right, so I think that's it for today's lecture. Any questions before let me stop sharing. Any questions before we dismiss?
I just want to confirm that participation questions this week are still due on Thursday.
Yeah.
Okay.
Any other questions? Okay, seems like, yeah. Good, and we'll go back. If you're energetic, learn the module 10 tonight. Okay, I'm just joking. Okay, take a eat a good dinner and have a good night. And thank you so much for being here tonight. And I will see you next Monday. Okay. All right. Bye. Thank you. Bye bye. Thank you. Thank you, Carrie.
Thank you. I got it. So thanks.
Thanks.